All right, good evening and welcome to the Peregrine Audubon evening presentation. This is our first presentation of the year, so we're pretty excited. Let's see, you can turn on your videos so we can see your faces for a few minutes. Then we'll have you turn them off, but keep your sound off, please, because that will interrupt us. My name is Maricela de Santa Ana, and I am on the Peregrine Audubon board. And we have these presentations on the third Tuesday of every month. And we have a few lined up already, and we're really excited about them. Tonight's is called Birds and the Marine Food Web by Tim Bray. And on Tuesday, October 18th, we're going to have a program called Climate Smart Solutions for Grassland Birds, Conservation Ranching in California with Matt Allshouse. And if you want to know about our programs, if you go on our website, which is peregrineaudubon.org, you can find out about all the presentations that are happening and their dates. And we are happy to announce that we are starting field trips again. And our first field trip is happening on Saturday, this Saturday, September 24th. And unfortunately, it is full because it has a capacity of 20 people, and 20 people have already signed up. Our other field trips are not like that. So this one is because it's on the City of Willits wastewater treatment plant property, and they are a little nervous about us having more than 20 people come. Usually, we also are going through the Willits mitigation lands, and usually I also have a limit of how many people can come because I lead those trips. So if you are interested, you could put your name in the chat, and if somebody drops out, I can call you. If you leave me your phone number, I can give you a text and let you know that somebody's dropped if you want to come. And that's on this Saturday. The next field trip is going to be on October 22nd, and it's also a beginner's field trip. If you are a beginner birder and are interested, it's at the Ukiah wastewater treatment plant. And you don't have to be a birder to go, though. I mean, a beginner to go. I think it's a really fun field trip. I try to go every year. It's very informative and fun. And that is on October 22nd. And then the one after that is November 19th. And that's to Covelo. And we'll be seeing lots of raptors there too. So let's see what else. Business, a little bit of business. Please join Peregrine Audubon. We don't have face-to-face meetings anymore. We're hoping to have them and start them in January, but still with this COVID thing, we're trying to be careful. So we're waiting till January. But in the meantime, if you want to join the Peregrine Audubon, we would appreciate that, because usually at these programs, we pass around a can and we then get donations, and we can use that money for things like our VOEP, Ribbon Valley Outdoor Education Project, or scholarships for Ukiah and Willits students. So do join the Peregrine Audubon. We would appreciate that. And let's see, what other kind of business. If you have questions, we would really like you to put them in the chat, and I will make sure that Tim, who is our speaker tonight, and I'll be presenting him in a minute, can answer them. He did say that he has a few little breaks that he'll take, and he'll ask people if they have questions then. But be sure to leave your sound off, because it can be very interruptive if people ask questions or make noises in the middle of the presentation. I see I have two people in the waiting room. I'll let them in. So without further ado, I'm going to introduce our speaker for tonight, and that is Tim Bray. And some of you may have heard him on the radio. He not only does the Celtic program on the weekends, which is really fun, but he also co-hosts the Ecology Hour with Dr. Robert Spies. And he is a retired hydrogeologist and currently the president of the Mendocino Coast Audubon and in charge of the Christmas bird count. And he's a person that is a very much a marine enthusiast and does pelagic trips with that group. And if you're interested, you could talk to him about that. He's an avid birder and he's a good photographer too. He didn't say that himself, but I've seen some good photographs he's taken. So without further ado, I'm going to let him take over. Thank you, Tim.
Thank you, Maricela. Thanks very much indeed to the Peregrine Audubon Group for inviting me to give this talk. It's quite an honor for me. Actually, I am not really all that well qualified compared to a lot of you. In fact, there are probably several people in this audience who are more qualified to give a talk about seabirds than me, but I'll give it my best shot. I did give this by invitation to the Noyo Center for Marine Science a couple of months ago. So that gave me a little bit of confidence to go ahead and talk to birders about birds. I am going to talk quite a bit about the science that goes along with the food web concept, and but there will be plenty of bird photos to go along with as well. Let's see if we can get started with this. Is everybody seeing my screen okay? Maricela, is that is the screen share working fine?
Yes, the screen is good.
All right, good. You can all see that tufted puffin and the little pigeon guillemot with an anchovy in his bill.
Yes.
All righty. Yeah, well, let's get to this. Okay. Before I get started, I just wanted to actually give a nod to the guy that took me out pelagic birding and introduced me to the magic that is the offshore world, and fond farewell, I guess. This talk is kind of given in the memory of Ron LaValle, and yeah, I don't need to tell most of you any much about him because you probably knew him better than I did, some of you, and but he did leave a huge mark and make a big difference out here on the West Coast. And there are an awful lot of us that go out to see and look at these birds now, who were introduced to that whole idea by Ron. You'll see a bunch of his photographs in here, of course, as well. I want to start with a couple of the scientific concepts that are sometimes conflated or confused, and make a distinction between the idea of a food web and a food chain. Most of what I'm going to talk about is the food web, but there's also food chain concepts that have a big impact, and I want to make sure we understand the difference. So this is a pretty common way of representing the food chain, a very simplified picture of what goes on in an ecosystem, and it's a step-by-step kind of hierarchical diagram that humans are so fond of. And what it really is a way to think about energy transfer. And from that standpoint, the arrows actually point in the wrong direction. Most food chain diagrams do this. They show they look at it from the top down, because we're usually up in that upper level. So you think about the big animals eating the small animals, and big fish eating little fish, and little fish eating even smaller things. But what's really going on is a bottom up transfer of energy, and it starts with plants. All food chains start with plants, basically, because they are what's called the primary producers, and they take sunlight and use that to transform dissolved inorganic carbon into molecules that store energy, and then that is available both for the plant to use, and then it's available for the herbivores, the things that eat the plants. And that's where the food chain starts. So it all begins with the plankton, and in the case of the ocean, it is largely but not exclusively about phytoplankton. We'll get into the macrophytes and why they're important as well. But most food chains will start with phytoplankton and then show you zooplankton that are eating the phytoplankton. So that's the first level of carnivores that are grazing on microscopic plants in the water. And then tiny fish eat the zooplankton, and then big fish eat the tiny fish. And most food chain diagrams will, as this one does, show the big fish eating birds at the top of the food chain. But that's way too simple. There's a lot more going on than that. This is still an overly simplified picture of a food web. And The difference, of course, is that the pathways go all over the place. These diagrams can be kind of confusing. This is actually almost a cartoonish one, but it's still in the minute or so that I'll leave it on the screen. It's unlikely you're going to work out the entire food web here. But the idea is there is a lot of crosswise action going on. In other words, it's not just a one-way transfer of energy. There are things eating other things and then returning back into the food web at various different levels. So this gives you a picture of the complexity that's going on, but keep in mind that there's still an energy transfer at each stage in these things. So every one of those pathways involves transferring energy from one level to another. And every time that happens, about 90% of the energy is actually lost. So only about 10% of the energy is passed from, say, the phytoplankton up to the zooplankton. And then the zooplankton are consumed by the pelagic fish, and they only get about 10% of the energy that was contained in the zooplankton. That's kind of a rule of thumb. Obviously, it's not rigorous, but it gives you an idea of what's going on energy-wise. And that winds up being really important to how the ecosystem works and how birds participate in these food webs. The other nice thing I like about this diagram is that it shows the birds actually participating in more than one way in the food web. Look over there on the left-hand side, they've got an arrow going from the benthic vegetation, macrophytes, which is just the fancy scientific word for seaweed. And there are birds that graze directly on that, like these little guys. These are black brant. I took this picture in the cove at Little River at Van Dam State Park a few years ago. They don't stay here very long. They migrate through because they are eelgrass grazers. So these are herbivorous geese, basically. Most geese are actually. Not very many herbivorous birds, but these guys specialize in eelgrass. You can see that one on the right has got a little piece of eelgrass actually sticking out of his beak. So they are jumping right in at the bottom of the food chain and grazing directly on the primary producers. Now these guys, you see western sandpipers running around on mudflats a lot, probing in the mud. And for a long time, it was assumed that they were getting little arthropods and worms and animals out of the mud and consuming them, and they are. But what has relatively recently been discovered is that they are also gaining quite a bit of nutrition from what's called the surface biofilm. So they're actually slurping up this very, very thin layer. It's only maybe 50 to 100 microns thick, right on the surface of a mudflat that is enriched in diatoms and zooplankton. And so they are basically grazing right on the phytoplankton that are at the base of the food web. Now, the macrophytes. There is another great scientific jargon term that I'm going to throw out for you because it's just too good to pass up. The seaweed that winds up on the beach, the technical term for that is the macrophyte rack subsidy. So beach rack is the junk that the ocean throws up on the beach. And in this case, we've got giant or bull kelp and bladder rack that get torn loose by the wave action. Those plants have extracted nutrition out of the seawater and constructed their structures with them. And then they get torn loose and thrown onto the beach, and that transfers a bunch of nutrition out of the marine environment and onto the littoral environment, where it is then food for that host of flies that you can see buzzing around. There's a whole bunch of arthropods that inhabit these piles of beach rack, and of course, thousands of shorebirds that come along and feast on those arthropods, like this pectoral sandpiper. So this actually is an extremely important kind of nutrient cycling, bringing nutrition out of the sea and throwing it up onto the shore where it can be made use of by terrestrial animals. Solitary or pectoral sandpipers aren't seabirds. So some people might think they don't belong in this talk, but here they are feeding on the nutrition that came from the seawater. Now we're going to get out into the actual seabirds, birds that spend nearly all of their time on or in the water. This beautiful picture of a surf scoter from Ron is just worth looking at, but they have that that giant comedy bill, which they use to forage in the mud and sand at the bottom. They are benthic feeders, and they root around in the mud, in the sand actually, and dig out clams. So a big part of their diet is bivalves, clams and even mussels. And they don't usually crack them with the bill, they swallow them whole, and then they have a massively powerful gizzard, and they swallow gravel and even barnacles, and then use the gizzard to crush the clamshells and then digest the meat. They also actually eat a lot of other benthic life, in particular polychaete worms that live in the sand and mud at the bottom. But that's their specialty. They dive from the surface to the bottom and feed right in the bottom mud. They're not really in the water column. These guys are also largely benthic feeders, although they're a little more generalist. This is a pigeon guillemot with their beautiful bright red feet. The inside of their mouth is also scarlet. So they're a really striking bird with the white patches on their wings. They breed on the offshore rocks here in crevices in the rock, and you often see them diving in fairly shallow nearshore water, often very energetic water. And sometimes you'll see them with anchovies, but often you see them with, as this bird has, these eel-like fish that live in crevices in the rocky substrate. And not very many birds actually feed on these things because they're a little tricky to get at, being in rocky crevices. But that is the specialty of the pigeon guillemot. They really dig on these little blennies and monkey face eels and things like that. And you see them all the time coming up with those. This little rhinoceros auklet has got himself a mouthful of sand lances. Now these are an extremely important forage fish for a lot of different birds and a lot of other life as well. Whales and of course a lot of fish feed on these things. They live in the substrate. They, as their name suggests, they burrow themselves into the sand. So they require a sandy bottom, and they live at various depths, but for the most part, their habitat is reachable by diving seabirds. Some of these seabirds can dive to tremendous depths. This rhinoceros auklet is not maybe the super best diver, but they can go maybe down to about 180 feet, although there have been records of them seen diving up to 300 feet. Now you think about that for a minute. The pressure at that depth is immense, it's something like 150 psi. So it's not at all clear how, what kind of physiological adaptations they have that allow them to survive that kind of pressure. And they just dive down and then swim right back up to the surface with no harm done. It's a remarkable thing, and a whole lot of these seabirds actually do that. Some of them even more extremely, as we'll get into. Well, since we're talking about fish now, there are way too many birds that specialize in eating fish in the nearshore marine environment to even go through in an hour-long talk. Just way too many. Even I can't even cram them all into one slide. I just have some representative specimens here. There's at least, 4 different species of grebe just here off the Mendocino coast, common murres. There's 2 different kinds of murrelet, 3 kinds of cormorants, several terns. The ospreys and bald eagles eat, osprey, of course, are fish specialists, and bald eagles eat a lot of fish as well. The marine merganser, pigeon guillemots that we already saw, there's at least 3 species of loons, and then various birds that I didn't have room to put on the slide. So all of these birds are piscivores. They're all feeding either exclusively or mainly on fish. Where are all these fish coming from? Why are there so many different species of birds crammed into the coastline here? They're right in the band of a couple of miles from shore. Where does all that food come from? And that brings us to some of the scientific concepts that I want to talk about a little bit. And that the first one is upwelling. This is something you probably have heard of. And if you're like me, you didn't quite understand how it worked. And so I'm going to try to give a quick explanation that will make sense to you. So the wind blows, as we know that live here on the coast, and it blows out of the northwest primarily. And it turns out our coastline is oriented northwesterly, so the wind is blowing parallel to the coastline. So for a long time, I did not understand why that caused upwelling, because it seemed like it just moves water parallel to shore. But what actually happens, there is something called the Ekman transport. And some Norwegian guy in the 1920s went out with some sailors, 1820s, I'm sorry, went out with some sailors who pointed out to him that icebergs do not drift downwind. They drift at an angle to the wind. So he did a bunch of figuring out and discovered that the rotation of the Earth actually causes the movement of surface water and icebergs, the wind-driven surface water, to go at an angle that is variable depending on where you are in which latitude you're at. But here where we are, the net direction of movement is almost 90 degrees from the direction of the wind. So it's a little counterintuitive, but the wind blows from the northwest and it winds up pushing the surface water straight out to sea. And when the warm surface water, that oxygenated water, moves off to the west, then something has to replace that water. You can't have a hole in the ocean. So that is replaced by water that comes up from the depths. And in particular here on the Mendocino coast, the continental shelf is not that far offshore, maybe 20 miles. And there are these big, deep submarine canyons that tend to just funnel this deep, cold water up from the abyssal plain and just basically push it right into the nearshore environment. And this is really important because that water is chemically different from the surface water. Let's get into that a little bit. So this is showing the same thing, the same phenomenon, although confusingly, it's reversed 180 degrees. This is looking north, the last slide was looking south. But it's the same thing, winds out of the northwest, blow parallel to the shoreline. That causes a seaward current that carries surface water away, and then that is replaced by the deep cold water coming up from the depths. Now that water has very low dissolved oxygen. It's been consumed by biological processes. It is loaded with nutrients because there is a constant rain of organic matter falling from the surface of the ocean, basically dead plants and animals. And it may be slow, but it never stops. And so it builds up a layer of water at the bottom that is basically saturated in the dissolved remains of all that life, including a lot of dissolved inorganic carbon. And then that gets pushed up into the shallows by upwelling. The wind blows on it, the sun shines on it, and you get phytoplankton and a phytoplankton bloom. You can see this happen here in the springtime when the winds blow and then stop for a few days. And about 2 to 3 days afterwards, you'll see the ocean turn green. Sometimes it'll look like pea soup. And that is a phytoplankton bloom. They happen repeatedly. And as long as the wind keeps blowing, the upwelling keeps happening and the phytoplankton will keep growing. It's analogous to spreading fertilizer on your lawn. If you just put some on once and then stop, your lawn will turn green and grow like crazy and then stop growing. It runs out of fertilizer. But if you just keep fertilizing your lawn, it will just keep growing and growing and growing. And that's what's happening in the nearshore marine right off our coastline. You can get these continuous phytoplankton blooms basically all spring and summer long. So this is what's called a eutrophic system, meaning well-nourished. And in the system like this, not only do you get a lot of phytoplankton, but you get a particular kind of phytoplankton, and this really matters a lot. It leads to the growth of large phytoplankton, mostly diatoms. And by large, I mean these things can be around 50 microns, maybe even 200 microns across, large enough to be seen with the unaided eye. These large, massive diatoms mean that there is more energy available for the zooplankton and the small fish than there would be if they didn't get that large. It's an interesting phenomenon, and I'll talk more about that when we look at the what happens in the open ocean, where you don't have all this upwelling and you don't grow the large phytoplankton. First, I want to show you a picture of what this stuff looks like. I took this from my kayak a few weeks ago, right offshore out here after one of these big phytoplankton blooms. And the large diatoms, as they grow, they tend to agglomerate, and they exude this kind of a sticky goo that is rich in carbohydrates and it has oils in it and sugars, and it makes them sticky, so they form these big floating mats. And of course, it also makes them nutritious. So a whole bunch of things in the water grazes on these gobs and mats of phytoplankton. The zooplankton, the carnivores, get to work on it right away. These phytoplankton blooms will happen in about 2 to 3 days. And then within about another 2 to 3 days, there will be a zooplankton bloom where the population rises exponentially, and they just start consuming phytoplankton at a very rapid rate. And again, if we didn't have upwelling and continuous repeated upwelling, though the zooplankton would quickly grow to a population that would consume all the available phytoplankton. And then the water would go clear again. And we see this happen sometimes when the wind stops blowing. You'll just notice that one day the water has suddenly gone clear and blue. And that's when the zooplankton have actually caught up and ate all the phytoplankton out of the water. These guys are an extremely important part of the food web. And we'll spend some time talking about some of the different things that eat them. So northern anchovies, we had a boom year for them last year, and we're having a pretty good year again this year, which is unusual. Normally a big boom year like last year is not followed by another high population year for northern anchovies, but for whatever reason, we've got 2 good years in a row going on. Notice that one guy there in the middle with his mouth open. They have these huge mouths, and they are filter feeders. They swim through the water column with their mouths wide open like that, and they have these little structures on their gill rakers that allow them to strain tiny particles of food out of the water. So they're grazing directly on microscopic plankton. And that means that since there's a lot of it in our water, these schools can grow to very large sizes and include immense numbers of individual fish and immense masses. They are energy dense. They're a fairly oily fish, and so they provide a tremendous food resource for everything else in the environment, including these guys. Brown pelicans, about 92% of their diet or more is anchovies. They are extremely dependent on northern anchovy for their success, and so you see them kind of boom and bust, and you also see them congregate in areas where there are large resources of anchovies. And last year that was the Mendocino coast. We had just an unbelievable year with brown pelicans. I estimated that there was somewhere over 10,000 of them on the whole coast. Every rock was completely covered in them. And you think about that, in 1972, I think it was, there were 500 pairs breeding in California. So 1,000 birds. And last year you could see 1,000 birds sitting in one place in Mendocino, and they were all up and down the coast. So it's a tremendous success story, conservation wise, and also spectacularly fun to see. Okay, come on. There we go. So this is some of the action that was going on last summer. Roger took this picture off Ward Avenue, where there was a basically nonstop show of pelicans dive bombing right behind the surf line pretty much all summer long. And so you see these brown pelicans sitting on the water, scooping fish up, and that one in mid plunge dive going after them. And then notice the gull sitting right underneath the diving pelican. Pretty kind of a pretty gull with the smoky gray head and the red bill is Heermann's gull. They are kind of partners with the pelicans. Well, not really. It's not an equal partnership. They are kleptoparasitic. The Heermann's gull follows brown pelicans around, waits for them to scoop up a pouch full of water with some fish in it, and then the pelican has to spit out the water and in order to swallow the fish. When they do that, they usually spill a fish or two, and the Heermann's gull will zip in there and grab it, sometimes right out of the bill. I've seen them actually stick their heads right down into the pouch to steal a fish. They're remarkably bold. But in the summertime, you just see them side by side all the time, the Heermanns and the pelicans. Between that, to the left of that diving pelican is a dark bird that is a juvenile Heermann's gull. They don't get that pretty gray head until they mature. There's some western gulls over the left and a harbor seal poking his head up in there. And in the blurry background, there are some common murres. Everything in this picture is eating anchovies. Common murres, these are very abundant and very noticeable seabirds, and they are true seabirds. They spend most of their lives on the water, except for the breeding season when they get onto the rocks just long enough to hatch the eggs and get the chicks about 2 to 3 weeks old, and then push them off the rocks into the water. So before the chicks can fly or even dive, they fall off the cliffs and splash into the water, and then the female murre takes off and leaves the chick in the care of the male, and he has to feed both himself and his chick for the next several weeks until the chick is old enough and large enough that it can fly and feed on its own. Really quite an interesting life history. The thing I really want you to look at on this bird, beautiful picture from Roger. Notice the wings in relation to the body size. These birds, they look like flying footballs when they're zipping by out there, because they have a big, heavy looking body and their wings are kind of small. They actually have the highest wing loading of any seabird, meaning the amount of air pressure that the wings produce, the ratio of body weight to wing area is higher than other seabirds. And so when you see them fly, you notice that they are continuously flapping. They can't really soar because their wings don't produce enough lift, and they just have to keep flapping in order to stay aloft. It's a very, very energetic mode of flight, and it requires a high energy food source, like, for example, an oily fish like anchovies. So their success is really tied to how well the anchovies are doing, which in turn is tied to how well the upwelling is going. And in years when that fails, or if you get the worst case scenario, a downwelling event, when the wind turns and comes out of the south, then the murres can suffer very badly. And we had a wreck of common murres a few years ago when exactly that happened. We had south winds in May and caused downwelling and just wrecked the anchovies, and it wrecked the common murres. So what they do in that case, they just give up on breeding. They can't feed themselves and their chicks, so they just quit and leave and live to try again another year. They're fairly long-lived birds. There's some other birds that feed on these anchovies at different times of the year. This is a pelagic gull known as the black-legged kittiwake. We saw this was photographed on a whale watch cruise. A few of us were birding off the bluffs, and we could see flocks of birds about 2 miles offshore, and we couldn't tell what they were. So we kind of commandeered a whale watch cruise for a couple of hours and got out into the middle of them, and it turned out to be hundreds of black-legged kittiwakes that were out there, like everything else, just gorging themselves on anchovies. It was really quite remarkable. Some birds don't bother catching their own fish. This is one of those. There's a whole class of them called Jaegers, and this is the parasitic Jaeger that I don't know why they singled this one out to call them parasitic, because they're all parasites. Their mode of making a living is to go find another bird that has caught a fish and beat him up and take the fish away from him. Notice again the wings. Look at how big that wing is compared to the body of the bird. The aspect ratio is completely different, and these birds are built for not only swift but extremely agile flight. So what they have to be able to do is fly faster than a murre or a kittiwake, and also they have to be able to catch up to them. So they have to be both fast and agile, and that requires very large wings. And so they're suited for that, all right. These are an offshore bird, a seabird. They spend their entire lives far from shore. Parasitics you can sometimes see because they will chase terns, and the terns will come up into bays to try to get away from them. And the parasitic Jaeger will sometimes pursue them all the way into the mouth of the bay. Most Jaegers are only seen on pelagic trips or very rarely seen from shore. They're quite a sight. Not everything is eating fish. These little guys are kind of specialists in a particular form of feeding on what are known as rack lines. So if you look in this photograph, you can see all the little birds bobbing around on the surface, and unfortunately you can't hear them. It was a quiet day out there, and they were talking to each other, and they make the cutest little racket. But if you look at the water, you see all that foam, and you can kind of see that it forms a line. And this is a rack line in the sea, and it forms where two bodies of water converge. So the water outside you can see is kind of rougher looking, and that water is probably going from north to south. And then the water on the inshore was actually not moving at all. It was still. Sometimes there's a counter current, sometimes it's just stagnant water. And the line where those two bodies of water converge is a rack line, and it tends to concentrate a lot of floating debris, and that means a lot of food. These guys bob along like little sewing machines, picking insects and arthropods and little tiny larval fish and all kinds of minute creatures out of that surface floating goo that forms where these two bodies of water come together. This is just a little close up of the same group of birds to show you that there are two species. Redneck phalaropes are the ones most commonly seen close in, and it was unusual to see the red phalaropes that are more of an offshore pelagic bird. But this was just a few weeks ago, just outside the buoy at Albion. So it was less than half a mile from shore. Quite a little sight. This is an aerial view of that phenomenon I was talking about, the convergence of two bodies of water. So on the right, you have probably nearshore water that is very nutrient rich and probably has phytoplankton bloom going on in it. And then that blue water that's more clear to the left is probably the outer water. And so there's two completely different systems going on here. The phalaropes will be following that line, and a lot of other things do as well. Let's talk a little bit now about the open water. I guess this is probably a good spot to stop and see, does anyone let me just stop sharing for a second. Does anyone have questions so far? Anything that came up that you want to hear more about before I move into the open ocean?
You can put them in the chat if you'd like. Questions in the chat. I think you're all muted.
Yeah, that's fine. I wouldn't like to get bogged down because I still have quite a bit to get through.
Yeah, I don't see any questions in the chat box.
Okay, good. Well, I probably have succeeded in putting everybody to sleep, so that's
No, no, it's,
that'll.
there's thank yous in there. I'm learning so much. You're doing great.
Well, you know, Maricela said that you all had absolutely nothing better to do for the rest of the night, so I can talk as long as I want. So. Okay, so the opposite of a eutrophic system is an oligotrophic system, an undernourished system. And in these systems, a number of interesting things happen. One is there isn't enough of certain micronutrients. It's actually one of the key things that's missing is usually iron. So those large diatoms can't grow. They can't build the structures that they need to make. And so this favors growth of smaller phytoplankton. And in fact, it favors things other than diatoms. Frequently, there are things like cyanobacteria and dinoflagellates that photosynthesize. Some of them are kind of halfway between animal and plant. But they also do other things, and dinoflagellates might raise a flag with some of you might have heard that word. They are often responsible for a condition called red tide. They produce toxins, and if they build up in large quantities, they can actually poison the environment and kill fish and birds and just about anything else that's living in the water. So it's a very, very different ecosystem than the well-mixed, well-nourished upwelling system. This is more what you get offshore, and this is what you get if the upwelling fails and the water warms up. If you notice down there where there's a kind of a big oval, there's a microbial loop. Bacteria get involved in this energy transfer. The small phytoplankton isn't available as food for things like anchovies. It's too small. Their filter systems can't gather enough of it up. So it has to be eaten by microscopic zooplankton before it can be available for the larger zooplankton, the larger but still very tiny animals that are fed on by everything else. That introduces one or two more steps to the food chain. And you remember I told you that now and then my page down doesn't seem to want to work. Let's just see. There we go. Remember I told you that we lose about 90% of the energy at each one of these stages. So these are what's called trophic pyramids. Well, they're not really pyramids, are they? They're triangles, but imagine a pyramid because they are on a logarithmic scale. So the kilojoules, kJ is a unit of energy. So this is just kind of a diagram of energy at each level of the food chain. We're back to a chain concept here. And on the left is the upwelling system, where you can have a food chain with only 3 links, where you start with these large diatoms, and they're fed on directly by relatively large herbivorous organisms, primarily things, the most important ones are krill and anchovies. I will talk about krill in a minute. And then those in turn are fed on by all the other carnivores, and I mean everything. So krill, for example, are anywhere from ½ an inch to an inch long, and they're fed on by everything from the Cassin's auklet, a tiny little seabird, to blue whales. Now over on the right, this 5-stage food pyramid, trophic pyramid, at each stage you're losing 90% of the energy. So by the time you get to the top, just those extra 2 links in the food chain mean that you have 1% of the energy available that you do in an upwelling system. So a given patch of ocean in an upwelling system might support, say, 100 whales. The same patch of ocean would support 1 whale in a stratified offshore system. Just a way of keeping in mind that the energy isn't concentrated out there. The offshore system, the food resources tend to be scattered over a large area, and that has real important implications for the birds, and they have adapted to it. Here's a beautiful but complicated diagram of the pelagic food web. And I'll let you kind of stare at this for a bit. It's a nice diagram, but there's a lot going on. And there is a lot going on in the open ocean. First of all, let me draw your attention to the layers. At the near the surface is what's called the euphotic zone, meaning well lit. So sunlight will only penetrate down to a maximum of maybe 600 feet in very clear water. So that upper 600 feet is the photic zone, and the top half of it is the well lit part of it, where you have enough light that plants can grow. You also have enough light that predators can find the forage fish and eat them. And all the other little creatures that are being fed on have to have some way to escape those predators. And so they do that by sinking below the photic zone during the daylight. So there is a diurnal migration going on every single day in the open ocean that is of staggering proportions, actually. These small fish and squid and various other invertebrates are moving up and down in the water column at a quite remarkable rate every day.
Excuse me, there was a question about how far out is this? You may have said it.
Yeah, that's a good one. The upwelling and well mixed zone goes here, at least off Mendocino coast. It goes all the way out to the edge of the continental shelf, which is about 25 to 35 miles offshore. In other areas, it varies, but again, that Ekman transport that pushes the nearshore water out to sea, in some cases, that can push the surface water as much as 100 miles or 100 kilometers offshore. And so that's about how far out that upwelling system can extend. It varies a lot seasonally. So in the winter, the whole system shuts down, everything gets cold. And so it kind of sloshes back and forth to a certain amount. But the open pelagic zone starts generally at about the continental shelf and then extends out into the wide open ocean over the abyssal sea. And you can think of it as basically you're reaching this kind of thing about 30 miles offshore from Mendocino. But you might still have pretty rich feeding out there. Like last year, for example, we did a pelagic, and I think we got about 35 miles out, and almost the whole way out we were seeing schools of anchovy. I know we were seeing them 25 to 30 miles offshore. So that Ekman transport had pushed surface water that was enriched in nutrition all the way out to 30 miles. And we were over the continental shelf at that point. It was 2,000 or 3,000 feet of water. So in a good year like that, when there's a lot of wind, you can really mix the system up. But now think of the size of the ocean, right? It's what, 2,500 miles to Hawaii. So, and you're only halfway across the ocean at that point. So the vast majority of the ocean is this kind of food web where the surface is depleted in food. And there's this big up and down movement of the forage and prey species. And then correspondingly, there are a lot of species diving down trying to get at them, like the whales. The sperm whale is one of the deepest diving animals in the world. Before we leave this diagram, over there on the right, underneath the sperm whale is the squid, probably the single most important of all of the creatures that are being fed on, especially from our standpoint, because I'll mention some of the birds that really rely on them. But the fish are also a big part of it. Flying fish is in particular, and in particular fish eggs and the larval fish, which basically cannot sink below the photic zone. So they are forced to stay up there where the predators can find them. The krill and the shrimp and the copepods, all these small crustaceans, they move up and down, but they are generally close enough. They have to get up into the photic zone from time to time to get food. So they're up there where surface feeding animals can reach them. And then there's the jellies and the other gelatinous organisms like salps and ctenophores. Not a whole heck of a lot is known about their contribution to the food web. They used to be kind of ignored because it was believed that they didn't have enough nutritional value, and so not very many things would feed on them. Turns out that isn't true, and in part it's a flaw in the way science is done. One of the ways you figure out what, say, a bird is eating is to kill the bird and open it up and see what's in its stomach. And these gelatinous organisms are so digestible that if you do that too long after it's eaten, you won't even see them. And so these things have escaped detection for quite a long time in those kinds of studies. Well, let's get back to some birds here, shall we? These are birds that you can find both in the nearshore environment and well offshore. Their way of making a living out there in the open ocean is to dive down to where all that food is. Most of the medium-sized seabirds, small to medium-sized seabirds, are great divers. I mentioned the murre earlier. They're probably the champions. The common murre has been seen at depths, unbelievable depths actually. They have been seen diving more than 500 feet below the surface. It's just staggering to think about a bird being able to withstand the pressure at that depth, especially at doing it quickly. You know, they can't stay down there very long. They fly underwater, they use their wings. Most of these birds do that. These two guys, tufted puffins and rhinoceros auklets, they look very similar. In fact, that puffin on the left was initially missed when we saw these birds because we assumed it was another auklet. They are very closely related and they have very similar ways of making a living. And both of them are pretty good divers. Puffins go maybe to 300 feet max, and the rhinoceros auklets about the same. So it's staggering to think of, but they will dive down 100 to 200 feet or even more to get at their prey, which are largely krill and anchovies. Yeah, well, sorry, anchovies when they're abundant and in close, but the krill drift all over the ocean. And so these guys just go wherever the krill are. This guy is a krill specialist, or a crustacean specialist, I should say, because not just krill. The Cassin's auklet is a tiny little seabird. Roger really had to zoom in and blow this photo up to get one to fill the frame. They'll fit in your hand. They're about less than the size of your fist. They have a little bill, and they can eat small fish, and they do. They eat a lot of small and larval fish, but their primary prey is crustaceans, mainly krill, and those copepods, which are even smaller than krill, and take more energy to catch, but you don't have krill, it's worth eating copepods, basically. Again, they make their living by diving. They sure don't make it by flying. They are barely capable of flight at all. And I just love watching these out there because when they fly, they have to beat their wings extremely rapidly to stay airborne. They look almost like a chubby hummingbird. And then they have no landing skill whatsoever. When they decide to land, they just stop flying, and they don't put their feet out. They don't spread their wings to slow down. They just fold their wings up and crash into the water. The Cassin's auklet is one of my favorites. This is what they're eating, them and the blue whales. So you can actually see side by side, Cassin's auklet and blue whale, tiny seabird and the largest mammal on Earth, feeding on the same thing. This is one of the species of krill from the North Pacific. If you see those orange structures in them, that is the reason why salmon meat is orange, and it's also why blue whale poop is orange. And, we know that because sometimes we had a pelagic once. I think it was one of the ones with Ron, when a blue whale came fairly close to the boat, and as it went by us, just deposited a load in the water, and it was a remarkable color because they consume immense quantities of these krill. Here's another little crustacean feeder. Again, look at that little bitty bill, and look how low in the water this bird sits. This is Scripsis merlet. Merlets are hard to find on these pelagic trips. This bird was way offshore, and they are so tiny that they hide behind small waves. So you can kind of probably tell from this picture that it was a very, very smooth day. And that's merlet weather, when the ocean gets glassy enough that you can pick these little tiny birds out at a distance. If it's rough, they're very, very hard to see. But they're, again, great divers. They get themselves underwater and spread their wings out and fly underwater and go a couple of 100 feet in pursuit of those copepods and crustaceans and small fish. These guys have a totally different way of making a living. We are now into the tube noses, or procellariforms. And you can see the little bump on this guy's bill. And I'll talk a little more about them with some other birds later. But what I want you to notice, again, look at the size of those wings relative to the bird's body. These guys are the opposite of a common murre. They have a tremendously low wing loading. They are able to flutter along right at the surface of the water and pat the surface with their feet. They look like they're dancing on the water. And what they're doing is creating a little vibration, which attracts small fish and small crustaceans. I'm not sure why, but it does. And then they just get down there and pluck them right out of the water. This is a storm petrel, Leach's storm petrel. There are several species of them out there in the ocean. Very difficult to see because they're very small birds, and they typically fly very fast and are lost behind the waves before you can really get on them. This is a great photo of one showing that weird little feeding strategy they have. Now we're getting into the real open water birds, the ones that are adapted for long distance, low energy flight. So this is the northern fulmar, very common bird to see on pelagic trips here. They are an abundant bird. There are several million of them in the North Pacific. And take a look at those stiff, broad, long wings. They have the characteristic flight, like shearwaters. They alternate flapping and gliding. And then take a look at that curious structure on the top of his bill. That is where they get their name, the tube noses. And it's thought to have more than one function, but a really important one is there is a gland up there behind it that actually concentrates salt out of their bloodstream and creates a concentrated brine, which then drips out of that tube. So they basically have got a constantly running nose. And the reason they have to do that is because they cannot drink fresh water. These birds spend their entire lives over the ocean. The only time they're not at sea is when they're breeding, and when they do that, they're on a rock, on a cliff over the ocean. So they never have a chance to drink fresh water. Most animals have to have some fresh water to flush the salt out of their bodies. These birds never, ever drink fresh water. And so they have this special adaptation that allows them to excrete salt out of their nostrils. They also use those to sniff out their food. They have an extremely keen sense of smell. When we do a pelagic trip and put out a fish oil slick, these are usually the first birds to come in, and they will often just come directly in. You can see them coming straight at you. Their sense of smell is acute, and they are voracious feeders. The fishermen don't like them because they will actually they'll fly right up and take bait out of your fingers while you're trying to bait a hook. Very aggressive little birds. They do dive, actually, surprisingly. Not as deeply as the auklets and the other small birds, but they can get down maybe as much as 60 feet. They don't all feed on squid and fish. This one, remember I mentioned that those gelatinous organisms might be more important than people thought. Last year, there was a tremendous eruption of northern fulmars right in close on the coastline. And this one was just outside the rocks at Russian Gulch, feeding on a dead jellyfish. And I often wonder if this bird actually made it through the winter, or if that was a desperation move by a juvenile bird that didn't really know what he was doing. There were a lot of them that didn't survive the winter, as is probably true every year. with a breeding population of about 5 million birds, you're bound to have a lot of mortality every year. But it's just interesting to see them feeding on these weird forms of life. Okay, shearwaters. Now we're getting into specialized adaptations, birds that cover tremendous amounts of territory in search of food. So again, the wing angle, the aspect ratio, and as you can see, in a calm day, this water is just glassy. There's no wind whatsoever. These birds have a heck of a time getting airborne because they need a little velocity before they can get enough lift to fly. And they don't really like to flap that much. They do flap. Their typical flight is alternating flapping and gliding, but their flaps are kind of short. Their wing beats are short angles, and they don't generate a huge amount of lift when they do that. Very different from, say, a raptor. You know, you can watch slow motion video of ospreys coming out of the water, or a bald eagle or something taking off, and they have this almost helicopter-like motion to their wings. These guys don't do that at all. Their wings do not rotate. They just go up and down through a fairly short angle. So they have to run along the water if it's really flat calm in order to get airborne. So the reason that they have to do that is their wings and their muscles and their skeleton are all specially adapted for long distance, very, very low energy flight. There are a lot of them. Sooty shearwaters might be the most abundant seabird in the Pacific. I think maybe around 20 million, give or take a few million. And they breed down in New Zealand, or on some small rocks off of New Zealand. And then they fly all the way around the Pacific Ocean. And in the fall, on their return migration, when they're headed south back toward New Zealand, they will come in close to shore and form these humongous flocks. You can see over 1 million birds in one flock sometimes. This is actually what an event like this led to the famous Hitchcock movie, The Birds. It was actually sooty shearwaters that may have gotten poisoned by a red tide in August of 1961. And they got disoriented and flew into a town and started landing on buildings and falling out of the sky and landing on cars, and nobody knew what was going on. That's what led Hitchcock to write The Birds. Sooty shearwaters, believe it or not. This picture I got from the internet. This was taken down in, I believe, Monterey Bay, or maybe off Santa Cruz several years ago. This is a famous map that has been shown many times since it was produced a few years ago. When they fitted sooty shearwaters that were breeding down there on the islands off New Zealand, all of these seabirds used to be extraordinarily difficult to study scientifically, because the only time they ever come on shore is when they're breeding, and some of them only breed every other year or every third year, and the rest of their lives they spend entirely at sea. And so it was very difficult to know what they're up to when they're out in the ocean. Finally, they got technology to the point where they can fit little transmitters, little GPS transmitters with radios in them, onto these birds. They catch them at the breeding sites, put a transmitter on them, and then watch where they go. So these are the tracks made by I forget how many birds, but they fitted transmitters on a few of them and then watch to see where they go. So the blue tracks are their feeding routes when they're breeding. So that's basically their daily commute, which might be several hundred kilometers, going out to sea, getting stuffed full of food, and then going back to feed the chick. Then once they're done with that, they take off, and the yellow lines are where they go after breeding. And some of them go over to the coast of South America off of Chile. And then some of them just kind of wander around in the Southern Ocean for a while, and then they turn and go northwest, and they fly almost in a straight line nonstop all the way up to the sea off of Japan and Kamchatka. So then they spend so they've they bred in the austral summer. So they've been down there in New Zealand when it was summer down there. And then they turn around and fly up into the North Pacific just in time for our summer. So they are one of the birds that basically has a strategy of never ever enduring a winter. And then when they're done with their our summer, they congregate off the west coast of North America. You can see that very dense orange patch over there. That is what was going on in that last slide, where these birds all kind of congregate in a very narrow area, gorge on the abundant food resources that we have because of all that upwelling, and then they just fly straight across the Pacific Ocean back to New Zealand again. And this is a round trip of what, 15, 20,000 kilometers. It's just immense. And they can fly, some of these birds can fly, they think 1,000 kilometers a day. They can go for hours, maybe days without having, well, no, these guys, the sooty shearwaters flap. They aren't the real super gliders that the albatrosses are. But their flight is spectacular, and it's because they have to cover so much ground in order to always be feeding in summer. They're not the only ones that do it. They are accompanied by an unwelcome guest. These guys actually go even farther because the South Polar skua, true to its name, breeds on Antarctica. So they are even further south than the sooty shearwaters. And then, but they follow the same route. And once breeding is done, the skuas just tag right along with the shearwaters. And I say unwelcome because skuas are basically a large Jaeger, and they are also kleptoparasitic. They make their living by just following the shearwaters around and stealing food from them as fast as they can. Great big hulking brute of a bird, and famously tough. There's a hilarious description of some early naturalists who were trying to collect these birds and got one into the boat, and it attacked them, and they tried to kill it and couldn't, and then it finally escaped, and they were actually quite happy that it did so. Okay, we're getting down to the end now, and we're getting into the real gliders and the birds that are specialized for open ocean feeding. Pink-footed shearwaters are one of the other species. There are several species of shearwater, and I don't have time to go through all of them, even though they are all fascinating. These guys are not divers. They can maybe go just a very short distance underwater. So they have to cover a large area of the ocean and find some food that is close to the surface in order to feed on it. So they've got these big, long wings. They glide a lot more than sooties do and flap less, and they are much more energy efficient. And they also famously are often found around whales. And it may be apocryphal, but here's a picture that shows what I'm talking about. This also illustrates the difference between my photography skills and Roger Adamson's. But this, I took this just a few weeks ago, in late August, off Bodega Bay. And we had humpback whales show up, and sure enough, there were the sooty or the pink-footed shearwaters wandering around them. And it's thought that the pink-footed, because they need food resources that are close to the surface, they prefer to forage around whales that are feeding and maybe pick up some of the food that the whales spill out of their baleen. Okay, now we're down to the true long-distance soaring champions, the albatrosses. We have two species commonly in the North Pacific, and interestingly, they are both considered to be small albatrosses because their wingspan is only 6 to 7 feet, as compared with the big albatrosses like the wandering albatross that can be up to 12 feet. The black-footed is the most common that we have here, and they are prodigious flyers. They breed mostly on islands in the Hawaiian island chain, and they fly all the way over here to feed. You can see them sometimes only 3 or 4 miles offshore here, and basically they have flown here from Hawaii, a distance of what, 2,500 miles or so. They can do 1,000 miles probably in a day. Them and the other species that we have here, the Laysan albatross, very comparable in terms of their flying feats. Notice the extremely long wings and that droop that they have. It's pretty characteristic. This one is doing something that we often see albatrosses do, where it's just touched the surface of the water with one feather tip. They do this all the time. And their wings are extremely flexible, but they are locked in place. So albatrosses have a unique feature in their skeletal system that their wings lock into position when they're out, and it does not require any muscle contraction to hold their wings in that position. So they can literally fly day after day after day with no exertion. It costs them less energy to fly than it does to stand on land. So that's what they do, is fly their entire lives. The only time they're not flying is when they're actually raising a chick. Here they are feeding on their favorite prey, which is squid. They can dive a little bit, they can make shallow dives, and so they're going after squid because it is extremely nutritious, and as those of us that have eaten calamari know, delicious as well. This, I think, is the first Humboldt squid I ever saw. This was again on that bodega trip just a few weeks ago. I think when we figured out what it was they were eating, and I said, it's a Humboldt squid, and someone said, is it alive? I said, no, it can't be, or it would be eating the albatrosses. These things are voracious. Anyway, the Humboldt squid does that up and down daily migration, sinks down to great depths during the day and then rises up at night. You can sometimes see offshore here fishing boats going for them, shining a light on the water to attract the squid and then catching them. I have no idea why there was one here at the surface. There were no fishing boats anywhere nearby, but there was the remains of a Humboldt squid, and these two albatrosses got on it and were just tearing it to pieces and gobbling it up. This is our other albatross, much less common than the black-footed, but at certain times of the year, mainly in the winter and spring, we can find them offshore here. Last year we did a short trip, I think a 3-hour trip, and we found 2 Laysan albatrosses just maybe 5 miles offshore. It was really exciting. These guys again breed on the Hawaiian Islands and then spend the rest of their lives all over the Pacific Ocean, and are adapted for effortless long distance flight. It is thought they live a long time. Famously, the oldest known wild bird in the world is a Laysan albatross, a female named Wisdom, who is known to be at least 70 years old, and she is still raising chicks. They know that she is that old because she was banded 65 years ago, and they have to be at least 5 years old before they breed. Most of them are actually older than that before they breed, so 70 is her minimum age. They, again, are adapted for this effortless long distance flight as a way of covering the large area of the ocean that doesn't have very much food resources in it. And then when they do find food, they can just gorge on it. They will make these foraging flights when they're feeding a chick for several days. They'll fly for a week, sometimes more, and gorge on food, mainly squid, and then fly back and then feed the chick for several days while their mate takes off and does the same thing. It's a remarkable adaptation. They very quickly adapted to the presence of a new thing in their environment, which was fishing boats. And so famously, albatrosses learned to follow fishing boats around, and they learn this quickly because they have also a very, very keen sense of smell. And fishing boats, as you probably know, smell very much like fish. So an albatross can sniff out a fishing boat from quite a long way off and will zoom right up on it and feed on whatever scraps are being left in the water from the fishing activity. And this has been going on for a couple of 100 years. It is a problem for the albatrosses nowadays because of the fishing methods. They often get entangled in the hooks and nets, and there's quite a lot of mortality from that. Fortunately, the Laysan and black-footed albatross populations are actually fairly robust nowadays. We're getting right down to the end of it now. Just wanted to say that I have loved giving this presentation almost as much as these two albatrosses love this giant grenadier. This is an abyssal fish. We were over, I think, 3,000 feet of water at the time, and this fish came all the way up from the very bottom. I don't really know how, but there was a fishing boat in the vicinity, and probably was a black cod fisherman, and he probably brought this grenadier up, and once it's on the surface, it can't get back down again. These two albatrosses were eating on it and interacting, as you see, and also vocalizing. That was the first time I ever heard of albatross vocalize. And then shortly after this picture was taken, a blue shark joined the fray and started feeding on the same fish. And then, for a while, all three were just side by side chowing down on this fish. The albatrosses didn't seem to be the least bit worried about the shark. But I just put this in to show that there's more than one way for a bird to partake of the food web. So this giant grenadier is a part of the food web that would normally be completely inaccessible to an albatross because they're separated by thousands of feet of water. But the presence of humans has changed things and made some food resources available to these birds that they would not otherwise have been able to get. And with that, I will thank you all very much for your patience and listening to me go on and on about some of my favorite birds. I do have a bunch of people here to thank. As you can see, much of what I have just recited about the ecosystem, I picked up from the interviews that Bob Spees and I have done on the Ecology Hour with eminent scientists like Bill Seidemann and Stan Senner, and we just recently had a great conversation with Scott Weidensaul, who I know spoke with your group last year. He's just a fantastic speaker and a great guy. And of course, the birders, Ron, Dave, Chuck, and Bob, kind of the guys that helped me learn these birds, and our Chuck and Bob and Dave are still helping me learn these birds. I famously cannot tell Jaegers apart, so I keep trying, and someday I will get one. And then big thanks to Roger and Becky and Shannon for those wonderful photographs, and especially to all the scientists that have spent their lives working it all out. Thanks very much, everybody. That is the end of my presentation.
Wow, well, thank you so much, Tim. I learned a lot, and I know a lot of other people did too, because they mentioned it in the chat, and there are a few questions for you.
Okay, good.
I think you're a fantastic presenter. I just want to say that.
Thank you.
So let's see, where are those questions? I just saw them. Well, here's one it's simple. What time and days do you do the Ecology Hour?
Oh yeah, that's an easy one. We are on the second Tuesday of each month at 7 p.m. on KZYX. The Ecology Hour itself runs every Tuesday at 7 with rotating hosts.
Okay, now I know there were some other questions. It also says,
hold on a second. I got to let my dog out of this
I
office.
thought there was a dog crying somewhere. Let's see, where? Oh, I can't see that. Oh, here they are. Here we go.
All right.
All right. So from Robin Mitchell, she asks that she thought the Laysan albatross bred on the Midway Islands where their chicks were dying because the adults inadvertently feed them plastic. Am I thinking of another species?
No, that does happen. The Midway is the #1 breeding ground for Laysan albatrosses. And it's a fascinating story. Ron used to do research there. He had some great slides and did some great talks about the Laysan situation. And Doug Forsell has been there too. They have a number of problems there. Of course, it was a Navy base for so long during World War II. They left a lot of contamination. So for quite a long time, the chicks were ingesting lead paint that was flaking off of the buildings that they left behind. I think they did go finally just recently and do a bunch of cleanup. So there's hopefully less of that now. But there's a number of threats. Albatrosses in general are among the most threatened birds in the world. There are 2 or 3 critically endangered species, and none of them are really in what you call great shape because they have so many threats in their environment now.
Wow.
But yeah, that's true. Laysan albatrosses breed on Midway Island and a few other Hawaiian islands as well.
Okay. Thank you. And then Vishnu says, are those fixed wing albatrosses essentially just gliding all day long? Do they need some wind always then?
Very good question and very good observation. That is true. They do. And this is why they're very rarely found in the tropics. They are birds primarily of the higher latitudes, both northern and southern. So the nicknames are the Roaring 40s and the Screaming 50s, or no, the Roaring 40s, the Ferocious 50s, and the Screaming 60s. So those are the latitudes from 40 to 60 north or 70 north is the preferred habitat for albatrosses because they don't have to flap at all if the wind is blowing. I didn't have time to go into it, but they do a thing called dynamic soaring, and you probably better just look that up because it's too complicated for me to even explain. But they've known about it for a long time, and it's still kind of a little bit of a mystery how they do it. But in a nutshell, they use the wind, not only the speed of the wind, but the fact that the wind is blowing faster the farther away from the water you get, right? So the friction with the surface of the ocean slows down the wind. So there's a certain wind shear going on, and the albatrosses can use that wind shear to generate lift, and they can soar in this back and forth way where they are alternately climbing into the wind and then speeding up going downwind while making headway across the wind.
Wow.
And they can do all that without flapping. So they don't really know, but they think that they can probably go for days without flapping at all. They do know, thanks to these miniature transmitters, that they can remain aloft for tremendous periods of time. I think the record is a wandering albatross that they tagged it, and it left the breeding grounds, started flying, and went all the way around the Southern Ocean. So it circumnavigated the entire Southern Ocean without stopping. And it flew, I think, 15,000 kilometers in just one flight. Normally, they will stop on the surface to feed. They rest on the surface of the water. And the reason they need that wind is so they don't have to run to take off. Flapping is hard for them. The black-footed can do it. You know, we see them do it all the time here. But they would much prefer to have about a 15 or 20 knot wind blowing, and then they can just kind of lean into it and float up off the water.
Wow. So there's 2 questions related to that. Do seabirds let's say, are there any theories why albatrosses wingtips touches the water surface?
Oh boy.
Pictures.
That's a good one. I don't know, to be honest. It's related to the way that they're using that differential pressure, right?
Right, makes sense.
Yeah, there's a surface, there's a layer of air right close to the water surface that is behaving differently than the air higher up. And these birds are kind of floating on that shear layer between the relatively slow moving air on the surface and the fast moving air above it. And there is some kind of an effect there where they're just barely above the water surface. But I don't know why their wingtips do that they just barely touch.
Yeah, maybe it's they're diagnosing that pressure, who knows?
Might be.
Yeah, and then the other question I think is related to all this is, do seabirds instinctively avoid ocean doldrums?
Yes,
Mhm.
yes. They also, yes, they can. They're tremendously good at meteorology. So they can predict the weather, and they can predict it in both time and space, and either fly toward or away from meteorological conditions that they either do or don't like. So they definitely avoid the doldrums because they don't like it if the wind isn't blowing. So that's why, for example, we have no wandering albatross in the North Pacific. There is a single record of wandering albatross in the North Pacific. It's been seen, one bird. It was actually at Sea Ranch, believe it or not, in the 1960s. Nobody would believe it except they got a picture of it, and stayed there sitting on a rock for a few hours and then flew off. Was never seen again. That's the only time a wandering albatross has ever been seen in the North Pacific, because they don't cross the doldrums.
Wow, that makes sense.
Yeah.
Well, and everything else is a just great presentation, except for somebody said that they had a Jaeger at Clear Lake last week.
Holy cow, really?
Yeah, that's what let me see who that is. Oh, and then there's one more about sleeping on long distance flights. That was Martine.
Wow, that's a tremendous find to get a Jaeger over an inland lake like that. Yeah.
Yeah. But then the sleeping question is, what about sleep with these long distance flights?
Yeah, that's a good one. There's actually active research about that. They're trying to answer that question. Right now, a lot of it is speculation. We know that many birds are able to sleep while they're flying. They can.
Incredible.
Yeah, there's a couple of different ways they do it. One is what they call hemispheric sleep, where half of their brain goes to sleep for a few seconds at a time, and then the other half goes to sleep for a few seconds, and then they just alternate like that. And talk about power napping. That is some serious power napping.
Yes, wow.
But they may also basically just do micro naps while they're flying, where their whole brain shuts off just briefly, and then they can also set on the water if they need to. They set down on the water to feed, and they can sleep on the water if they have to, but they clearly do not have to, because one thing they do know is that they go days and days and days on the wing.
Well, if they have those fixed wings, they might actually be in a semi-sleep state, because they're just really resting on the wind while they're flying. I mean, it's pretty incredible. Well, thank you so much, Tim. I just feel like this was a great presentation, and yeah, I hope you'll keep presenting it.
Well, thanks. I'm glad it worked for you. Like I said, I feel a little bit like there's better guys to be doing this than me, but I just do, as you might have been able to tell, I get pretty enthusiastic about these birds.
Yes, and it comes through. It's really nice, that enthusiasm. I appreciate it.
I could talk for hours and hours just about albatrosses. There is no limit to the wonder and majesty and mystery of albatrosses. They're just the most amazing birds.
It makes me want to go on a pelagic trip with you, I'll tell you that. So maybe you'll get a lot of people from this.
That would be good. Yeah. You can send an email to audubon@mcn.org. And I put these together sometimes on short notice when the weather's looking good. We're lucky here in that we can, with a 1-hour boat ride, we can get out to the Noyo Canyon and have, we did one of these half-day trips. Last time we went out, we had 24 black-footed albatrosses in afternoon.
Oh, gosh.
And you can get Jaegers and skuas and all these open pelagic birds that in most places of the world you'd have to go, it takes you 3 hours just to get out where they are.
And you get marine mammals too.
Oh boy, do we ever.
Yeah. It's just a great thing. Yep. Well, I'm gonna wish everyone good night, and you too, Tim. It was nice that we could all stay home. It kept raining and raining here, so it was
nice.
Yeah, nice that no one's traveling around. we're all safe at home. And thank you again. Good night, everyone.
Thanks very much.
Yeah, thank you. You have lots of thank yous in the chat box.
Oh yeah, I didn't get a chance to look at that. Let's see.
Yeah, you want to look at it?
Yeah, let me just have a quick look here.
Yeah.
Yeah, how far are I out? Yeah, the plastics are one of the big threats to albatrosses. Apparently the adults can handle it, but the chicks can't.
Oh,
So it kills a
wow.
lot of chicks.
That's too bad.
Yeah, oh yeah, it's
Plastic is just such
very
a
much a shame.
problem. Yeah, there's just a lot of great presentations.
Okay, great. Well, thanks everybody for the nice comments. I appreciate it very much. It's really nice.
Thank you, Tim. Thanks so much for presenting to us. We appreciate it. You kicked off our year. We appreciate that.
All right, great.
All
See
right.
you on the water.
Yes, yes. Bye-bye. Happy birding.